Right now, a multi-million-dollar global certificate authority can be compromised not by like brilliant impossible math, but by a single customer support agent opening a fake screenshot in a chat window.
Yeah, which is just wild to think about.
Right. I mean, we always picture major cyber attacks as these cinematic events,
Yeah.
green code raining around a screen, some genius hacker finding a zero-day backdoor that literally no one could have anticipated.
Like the whole Hollywood hacker trope.
Exactly. But when you look at the actual threat reports on our desks today, that image just shatters completely. We are looking at the digital equivalent of a security guard accidentally leaving the back door propped open with a brick because they were holding too many coffees.
That's a painfully accurate way to put it. The plumbing of the internet is leaking.
Hmm.
I mean, attackers aren't using fancy drills to break in right now. They're just turning the handles that we forgot to tighten.
Yeah.
It's these mundane errors, the misconfigurations, the lack of basic authentication on new tools, the unquestioned trust in internal systems that are causing the most catastrophic breaches.
And that brings us to the mission for today's deep dive. We're here to give you a concise, high-impact cybersecurity briefing. Looking at this stack of technical write-ups, there's a very clear, very dangerous theme emerging, and that is the silent escalation of access. We're going to explore how tiny oversights and rush deployments are just handing attackers the literal keys to the kingdom.
We've got a lot of ground to cover today.
We really do. We're looking at a critical WordPress flaw, turning basic web requests into complete site takeovers, a new botnet hunting down the AI tools you just deployed, and how a cybercrime group hacked the digital chain of trust at DigiCert. So, okay, let's unpack this by starting with a vulnerability that affects a massive chunk of the internet, which is WordPress.
Right, the WP2 shell vulnerability.
Yeah, WP2 shell. It targets WordPress core versions 6.9 and 7.0. And I think it's important to clarify, when we say core, we mean you don't need a single third-party plugin installed to be completely vulnerable.
None at all. A bare default installation right out of the box is entirely exploitable.
Which is terrifying. So how does this actually work mechanically?
Well, it's a textbook example of a vulnerability chain.
Yeah.
It's not just one flaw. It's two separate bugs that, when stacked together, create a total disaster.
Okay, what are the two bugs?
The first is a REST API batch route confusion, tracked as CVE 2026-63030. And the second is a SQL injection located deep within the WordPress core, which is CVE 2026-60137. By chaining these two together, an anonymous, unauthenticated user can just send a single HTTP request and achieve full remote code execution on the server.
I want to break down exactly how this mechanical chain functions for you all because it relies on something called the batch processing endpoint.
Yeah,
Right?
exactly. WordPress has this specific route, WP Dason's batch v1, and it's designed to let developers run several sub-requests in a single API call.
Right, built for efficiency so you aren't making 20 separate trips to the server.
Yeah. And to keep track of these sub-requests, the backend system uses two parallel arrays. One array holds the routes, basically where the data is supposed to go, and the other array holds the actual data payload.
Right.
What's fascinating here is how fragile that parallel array structure actually is. Because if an error occurs in just one of those sub-requests during processing, the system doesn't halt.
It just keeps going.
Yeah, it throws an error, but just continues processing the next item. The problem is that the error knocks those two parallel arrays out of sync by exactly one index step. The route array shifts, but the payload array doesn't.
Oh, wow. So it's like a restaurant waiter holding two parallel order tickets. On the left ticket, you have the table numbers, and on the right ticket, you have the food orders.
That's a great analogy, yeah.
So the waiter makes a mistake and shifts the food ticket up by just one line. Suddenly, table 4 is getting table 5's order. In this digital version, the waiter accidentally delivers a customer's malicious, unvetted instructions directly to the head chef, which is the database.
Exactly. It completely bypasses the kitchen manager or the allow list, who is supposed to check the orders to make sure someone wasn't trying to, order a poisonous mushroom.
Right. So because of that index slip, a request ends up running under a completely different requests handler. The input literally walks right past the endpoint's security allow list.
Yeah, it takes the attacker's malicious input and drops it completely unvetted into a vulnerable parameter called author_noten within the WP query function.
And WP query is essentially the engine that WordPress uses to fetch posts and pages from the database.
Right.
Now, my understanding of the author note and parameter is that it expects an array of author IDs that you want to exclude from your search results. Like, it expects a list of numbers.
Right. Just integers.
But because of this misalignment we just talked about, the attacker can hand it a raw, malicious string of SQL commands instead.
Exactly. The PHP backend was written assuming that this parameter would always be an array. It was designed to iterate through an array and cast each item as an integer, which naturally sanitizes it.
Okay.
But when you feed it a string instead of an array, that specific sanitization loop just fails to trigger.
It just skips it.
Yeah, the system skips the safety check entirely and drops that raw string directly into the database query compiler. Boom, that is your SQL injection.
Wow. Okay, so here's where it gets really interesting and honestly a bit frustrating for security teams trying to prioritize their patching. The way this vulnerability is being scored by the National Vulnerability Database is incredibly counterintuitive.
Oh, it really is.
If you look at the actual remote code execution chain, the complete path that lets an attacker take over the server, it only received a CVSS score of 7.5. That's categorized merely as high.
Right.
But the SQL injection component by itself got a 9.1, which is critical.
Yeah.
How does a full server takeover get a lower threat score than a localized database query?
Well, this raises an important question about how rigid and sometimes misleading automated scoring metrics can be. The CVSS heavily rewards direct, unfiltered reach into a database. It aggressively weights confidentiality and data access.
Right.
But the root confusion, the actual mechanism that makes this SQL injection accessible to an unauthenticated attacker from the outside, is treated mechanically as a simple parsing flaw. So the formula for that 7.5 score only credits the data access. It completely ignores the massive loss of system integrity and availability that obviously comes when an attacker achieves full code execution.
So the system is essentially assigning a threat level to the bullet, but completely ignoring the gun that allows the bullet to be fired from across the internet.
That's exactly it.
Absolutely.
And that's a danger of relying purely on automated scanners and dashboards. If your IT team sorts their patching queue by CVSS score, a 7.5 might get pushed to next week, while they focus on a 9.0 that might actually require authenticated access to exploit.
Right, which makes no sense in practice.
Exactly. You have to track the actual CVEs and understand the underlying mechanics. A 7.5 high is a critical active zero-click threat when chained in this specific way.
So if you manage WordPress sites, what is the practical impact for your deployments right now? Last Friday, WordPress realized the severity of this and pulled the emergency lever. They issued a forced push update to versions 6.9.5 and 7.0.2 through their auto update system.
But listen, you cannot assume the auto update actually worked. You must physically verify your version numbers today.
Yeah.
The security advisory doesn't state how many sites were successfully reached by the forced push, and if you have auto updates disabled at the server level, you are sitting completely exposed.
And we already have a working proof of concept exploit sitting out there in the wild on GitHub. The patch was made public, so researchers and threat actors instantly reverse engineered the code diff to see exactly where the flaw was.
It didn't take them long at all.
No. And the only saving grace mentioned in the threat reports is that this specific code execution path fails if the site is running a persistent object cache, like Redis or Memcache.
Right, but a default install doesn't have Redis configured. It is wide open. And honestly, having a persistent object cache is just a side effect that happens to block this specific rote confusion. It's not a real fix.
Right. It doesn't patch the underlying SQL injection in the core.
Exactly. Update your WordPress core immediately.
Okay, but it's not just legacy platforms like WordPress suffering from these overlooked open doors. Attackers are taking this exact same path of least resistance into the AI tools we are all rushing to deploy.
Oh, absolutely.
Development teams are standing up these incredible new AI workflows at absolute lightning speed, but security is just a complete afterthought.
The rush to integrate AI is unprecedented right now. Teams are deploying local models, workflow builders, image generators.
Because the business demands immediate innovation.
Exactly. They are putting the tools up fast and thinking about the firewalls way too late.
Which brings us to a new botnet called NadMesh. This is a Go-based malware operation that surfaced in early July. It uses a Shodan harvester, basically continuously querying the search engine for internet-connected devices to constantly scan the web for exposed AI tools.
Yeah, we're talking about platforms like Comfy UI, Olama, NIN, Open Web UI, and Gradio.
Right. And the intelligence feed tracking NadMesh shows it systematically cataloging models like DupSeek and GLM. The threat researchers at Kiaxon's XLab actually managed to find the operator's own backend dashboard, which gives us a rare look into the scale of the operation.
It does, but
Well, I want to push back on the scale they are claiming, though, because if you look at the XLab report, the stats on the hacker's dashboard are wildly contradictory.
very true.
The dashboard claims 95,700 successful deployments in a single 24-hour period. But right next to that metric, it says there are only 16 active bots currently connected. Meanwhile, XLab's own external sensors only picked up about 139 distinct source IPs pushing this malware.
It's quite the discrepancy.
Yeah. So are these threat actors just artificially inflating their own metrics to look successful on the dark web? Because if their dashboard is this broken, should we even take this threat seriously?
It's a very fair skepticism.
Yeah.
The operator's own scoreboard is clearly broken, or at the very least, highly deceptive. But if we connect this to the bigger picture, the exact number of active bots doesn't matter nearly as much as the target itself.
What do you mean?
What makes NadMesh terrifying isn't a massive bot count. It's the specific data those bots are programmed to steal.
So they aren't just trying to hijack the computer's GPU to mine cryptocurrency like older botnets did.
No, they don't care about the host machine's compute power at all. They want the access that the box inherently possesses. They are digging for cloud credentials. They're pulling environment variables, Kubernetes service account tokens, the contents of hidden.env files, Docker configurations, AWS keys. The operator's dashboard, despite its other statistical flaws, claimed they had already harvested 3,811 unique AWS keys.
Wow, that is a staggering amount of lateral movement potential. To understand how they are getting in, we need to look at something called MCP, the Model Context Protocol.
Right.
MCP is an open standard that was recently developed to allow AI models to connect to external data sources and tools. It's what lets your local AI read your local files or query a database. And on the NadMesh priority list for exploitation, the MCP protocol is at the absolute top, ahead of even Kubernetes and Docker APIs.
Specifically, they are targeting an MCP JSON RPC call named execute command. It does exactly what it sounds like. It executes system commands.
And there is no CVE assigned to this, is there? Because it's not a bug, it's literally just a feature working as intended.
That's the scary part. It's not a traditional software vulnerability. When the MCP specification was first written, authentication was left entirely outside the core protocol.
Wait, really?
Yeah, it was assumed the transport layer would handle security. Even the authorization flow they added recently is completely optional. So you have developers deploying these AI tools with execute command enabled, and they just skip the authentication step to save time and reduce friction during local development.
That's like building a high-tech vault for your corporate data, but leaving the blueprint and the master key sitting on a table in the lobby because you were tired of unlocking the door every time you needed to test a new feature.
That's exactly what it's like. Attackers are scanning for this unauthenticated command execution alongside older, well-known vulnerabilities in Docker and Jenkins to get a foothold. And once NadMesh is in, the obfuscation they use makes it incredibly difficult for standard antivirus to catch them.
Right, they use some pretty advanced techniques.
They utilize a combination of garble obfuscation and UPX packing, along with random padding. This means they mutate the binary on every single compilation. No two NadMesh agents share the same file hash.
So standard endpoint detection and response tools that rely on blocking known malicious hashes will just fail completely.
Completely. If a security system flags one build and blocks it, the next bot that comes along will look entirely different and walk right past the defenses. Plus, it establishes persistence in 3 different ways, simultaneously using cron jobs and modified system binaries. If you find one piece and delete it, the other 2 just rebuild it.
Okay, so if you were running these services on your own infrastructure right now, what does this actually mean for your deployments? First, you need to lock them behind authentication immediately.
Today,
The specific ports the NadMesh RayScan jobs prioritize are 8188 for Comfy UI, 11434 for Olama, 7860 for Gradio, and 5678 for N8N. If you find any of these ports exposed to the public internet without authentication, we need to talk about incident response.
yeah, if you find an exposed host, you have to assume the keys are already gone, isolate the machine entirely from the network, and here's the most critical point of incident response. Revoking is not rotating.
I really want to emphasize that distinction because just hitting generate new keys in your AWS console is going to get you owned twice.
Exactly. If you just generate new AWS keys or Kubernetes tokens and place them back onto a machine that is still compromised by NadMesh, the attacker instantly gets the new keys. You must completely eradicate the persistence mechanisms first.
So wipe it.
The safest route is to pull the virtual machine down, wipe it completely, rebuild it from a clean image, and only then issue replacements. Otherwise, the new keys are piped straight back to the command and control server.
Okay, so NADMesh is about stealing cloud credentials to sneak into your infrastructure. But what if an attacker wants to bypass your Right. And the threat researchers at Expel identified Cylindrical Canine as a subgroup of a massive Chinese cybercrime syndicate known as GoldenEye Dog. Now, we should note here for you all that we are strictly reporting the findings of the Expel threat researchers who made this attribution.
Right.
We're just outlining the claims in their report. We're not taking a geopolitical stance on the origin.
Exactly, just looking at the technical data. So GoldenEye Dog has been active since at least 2015, usually targeting the gaming and gambling sectors by pushing malware disguised as legitimate software.
Okay.
But for this campaign, they needed high-level digital signatures to make their malware look officially approved by Windows and other operating systems, bypassing security features like Windows Smart Screen. So they targeted DigiCert's customer support staff.
And the social engineering here is almost beautifully simple. They didn't burn a multi-million-dollar zero-day exploit to breach a firewall. They just contacted the DigiCert support team through a normal customer chat channel. They claimed to be a customer having a technical issue and sent a ZIP file disguised as a screenshot of the problem. But that ZIP file actually contained a .cr file, which is a screensaver executable.
And when the support analyst clicked on it, thinking they were opening an image, it triggered a classic DLL sideloading chain.
Walk us through the mechanics of that sideloading, because it's a brilliant way to evade detection.
It really is. So the .cr file drops two things onto the system: a known, legitimate executable program and a malicious hidden DLL file with the exact same name as the required system library.
Okay.
When the legitimate program runs, the Windows loader looks for its required DLLs. Because of how the search order works, it grabs the malicious DLL sitting in the local folder instead of the real one in the system folder.
Oh, wow.
Yeah, so you have a legitimate trusted application running a malicious payload in its memory space. Simultaneously, it pops up a fake PDF document on the screen that just says HTTP 503 service unavailable.
So the analyst just thinks the image failed to load?
Exactly, but in reality, the Golden Ghost remote access Trojan has just been silently installed on their workstation.
So now the attackers have full remote control of a DigiCert customer support computer, and this is where the system architecture completely breaks down. Once they were inside, the attackers used a built-in proxy function in the support portal.
Yeah.
This function is designed to allow an analyst to view an account from the customer's perspective to help them troubleshoot UI issues. But while using this proxy view, the attackers were able to see something called an initialization code for Approved Extended Validation, or EV, code signing certificate.
And this is where the flaw in the architecture becomes fatal.
Let's talk about why that is fatal. Because the Expel report noted that mere possession of this initialization code was functionally sufficient for the attacker to just claim the certificate for themselves.
Right.
I mean, is that like someone stealing your grocery receipt out of the trash and using it to legally claim ownership of your car? How could a single code be enough to hand over the keys to digital trust?
This raises an important question about threat modeling and the concept of zero trust. The system was designed with the assumption that the initialization code would only ever be seen by the legitimate customer in their own secure, authenticated portal.
Okay.
DigiCert's threat model simply never accounted for a scenario where their own internal support accounts would be compromised and used to view that proxy data. They assumed the perimeter of the support portal was secure. Because they trusted the internal network, the internal checks were incredibly lax.
And because of that massive blind spot, the attackers successfully intercepted EV certificates that were intended for real, legitimate enterprise customers.
Yep.
They took those certificates and used them to cryptographically sign their own Zong Stealer malware. To the rest of the world and to every EDR tool in the market, this malware now looked like fully verified, trusted software.
DigiCert eventually identified the breach and revoked 60 certificates, 27 of which were directly weaponized by this threat actor. They've since deployed a code change to mask those initialization codes from the proxy view. But, the damage to the compromised trust is already done.
The practical takeaway for your security teams here is that customer support portals are an absolutely massive attack vector. Your support staff are literally paid to open files sent by strangers on the internet.
Exactly.
Any file submission, any screenshot sent through a ticketing system or a live chat must be treated as a highly suspicious payload. You have to sandbox those environments completely. Never let a customer support workstation have direct, unmitigated access to sensitive production data without additional layers of strict authentication.
The human element is always the softest target, and attackers know that a support ticket is the easiest way to bypass a firewall.
All right, let's summarize the critical takeaways from today's briefing. First, verify your WordPress versions immediately. Do not trust that the auto update for WP2 shell worked, and remember that default installs are highly vulnerable.
Right?
Second, lock down the ports on any local AI models your developers are running. NADMesh is actively hunting exposed MCP ports and will steal your AWS and Kubernetes keys. And third, audit how your support staff handles customer attachments, because a fake screenshot can bring down a global certificate authority.
Today, we looked at a basic array parsing error in WordPress, an unauthenticated local port on an AI tool, and a fake screenshot dropped into a chat window. It highlights a massive vulnerability in how we handle trust. And I want to leave you with this final thought to mull over. If a single compromised support agent can intercept the cryptographic keys that secure the internet's software supply chain, we have to ask if the centralized certificate authority model is fundamentally broken.
Yeah.
Are we relying on an obsolete single point of failure architecture? Perhaps the future of digital trust shouldn't rely on a handful of global authorities, but rather on decentralized, blockchain-based cryptographic models where no single human error can hand over the keys to the kingdom.
The question every security architect should be asking themselves as we look toward the future of the internet. Thank you for joining us on this deep dive. Stay vigilant out there, check those basic settings, and we will catch you next time.